Hi everyone and welcome to this session. In this session, we are going to talk about data science, machine learning, and the different cloud platform that allows the capability to implement all of this, right? So we all know how big this buzzword is going upon, right? The data science, machine learning, and nowadays generative AI as well, right? So most of you would be interested to learn about generative AI, right? And it's a very interesting technology. But this particular session is for all those who want to know this that what generative AI is. And interestingly, you won't find the word generative AI on this particular slide, and there is a specific reason for it. For anyone who want to build a career in generative AI, we all should at least know at a very introductory level that what are the foundational concept behind the generative AI technology, right? And those foundational concepts you will find it in machine learning, and the foundational concept of machine learning you will find it into data science. So anyone who want to do generative AI using SageMaker, MLS, or Vertex AI, we all should try and make an attempt to know machine learning at the foundation level and then the data science. So moving on, we are going to cover this journey of learning all of this. And just to remind you again, this is an introductory tutorial, which doesn't mean that we are just going to do a hello world program. We are going to go a little beyond that, and at the same time I will try to keep things as simple as possible for anyone who want to know this journey. All right, bon voyage. And before we start our voyage, let's talk about our voyage itinerary that we spoke in the last slide as well. First, we are going to do data science. What is it? Machine learning. Let's hop over. This is our bus. This is our space shuttle. We are going to hop over the machine learning space shuttle. And finally, AWS SageMaker or any other IDE. Bring it on. All right, let's go to the first part of it. And I forgot. So this particular animation that you see at the bottom of screen is to tell that which section we are covering as of now, and this will be moving on as we progress further. The reason for this is, in my experience, I have attended so many sessions, try to understand the technology, and when I am new to a technology, sometimes I forget why I am learning this. What is it that I learned earlier and what is it that I'm going to learn next, right? So that to help that type of confusion, I have just included a small animation right down here. We are at the data science, and then this will keep moving as we progress further. All right, let's go on. Data science, what is it? As we know that when we talk about data science, right? Data and science, the science behind the data. So basically what is a data? And I think most of us, almost everyone know it, either a formal definition or an informal definition, right? The formal definition is basically, and this is not the only definition, data can be defined in 1,000 different ways, but at the very core, a data is a raw material that serves as a foundation for extracting valuable insights and knowledge, right? Now let that particular piece of information settle in settle in, right? So we are talking about a raw material, right? when we are going to when we are going to arrange this raw material, assemble this raw material in a particular way, we are going to get insights, we are going to get knowledge. So for every knowledge that we want to do, data is the very core, and especially in this world of machine learning and generative AI. Now, when we talk about types of data, uh, it is important to know that in today's world, data comes majorly into two format, right? When I say majorly, that means there are some other formats as well, but because we want to focus on an introductory session, we are going to talk about two important formats of data. One is the structured data, which basically stores the data in databases, Excels. People who I don't want to bring the word databases, honestly, it's there on the slide. But for all those people who even don't know a database, right? Don't get overwhelmed with the technological world, right? It's not a new technological. It's been there for decades. But think of your plain pure Excel, right? Which has rows and columns. This is a very well structured data, right? If the first column says name, then all the values in this first column will be the name of something, right? If the second column says age, then you can expect that the second column will have age all the way along in all the rows. So it is pretty structured, right? Now the next type of data, which is unstructured, right? And there is a humongous growth of this unstructured data, right? Which is text document, image, and social media post. Now, people who have seen the industry evolve in the last 20-30 years, they would recall that whenever we talk about data, then it was mostly structured either in an Excel format or in some specific format. Now, when we talk the data, how it has evolved in the last 10-15 years, then you would see a humongous growth on the social media platform. And what type of data do you produce or do you create on those media platforms, right? You are going to upload the image, you are going to upload the video, you are going to upload some codes, slides, and whatnot, right? There is no structure to it. You might be one person who want to put the quotes with an image. There might be some other person who want to put the video, some other person who want to put the blocks, right? So all of this is unstructured data. There is no fixed format, right? So we must know that the types of data are two types, structured and unstructured. Given that this is an introductory session, we will be focusing majorly on structured data to keep our things simple and to understand the concept of this whole technology. Now, importance of data in decision making. And there is one example that we are trying to understand, or we are trying to create an analogy between this whole technology of generative AI, machine learning, and with a child. So think of it that all of us have been a child once, right? At the very young age when we were babies, right? That time we had our brain. The brain was had a processing unit, right? It can understand, it can see, it can feel, it does know when to cry, right? So there is a special processing that has already started even when we were babies. What is it that we were missing, right? At that time we were missing the experience of this real world, right? And that experience is the data, right? So when we talk about machine learning, right, then very important thing, our machine is like a baby, right? And our data is the experience. Whatever data that we give to this baby, he or she is going to learn from this data and make decisions, right? Let me put it with an example here. So think of a baby who is sitting on the edge of a sofa, right? And as an adult, you might want to tell the baby in either in a sign language, or if the baby is able to understand what you are saying, then you will say that, okay, don't sit near the sofa, you are gonna fall, right? Now this is an information that you have given to the baby, right? The baby, which is an intelligent, if we can call it a super intelligent machine, behaves like a super intelligent machine. With this just one experience, when the child or baby sit on some other place which is higher than the ground, it is going to make a decision that when I was sitting on the sofa, I may fall. He or she might have fallen as well. From that experience, without anyone telling, that when you sit on a chair, as an example, which is higher from the ground, the same experience you are gonna get. That is the power of knowledge, right? And that is the power of human intelligence, right? And with all this thing, we are going to artificially create that intelligence to our programs, right? So this is a very important thing, that the type of programs that we are going to build, the core of that will be data, but the outcome of that will always be some sort of prediction, right? Now people who are in IT and maybe in different type of technologies like a reporting technology, or let's say developing a graphical user interface, they always know that if I give a specific input, for that specific input the output will always be same, as long as everything, all the environment has remained same, right? So all the programs that we have built other than machine learning programs, we can almost every time be certain that if I give the same input, if everything else remains the same, I can expect the same output, right? There is a fixed pattern here. But in the world of machine learning, with your experience, you can expect to get a different type of prediction, because we are bringing in the intelligence, and we are going to talk a lot more about it. All right. So for the moment, just grasp this concept that data is a very important thing to in decision making. Now let's talk about 2 points, which is the data quality, right? Data accuracy and consistency. Now the decisions that a child is going to make will very much depend on the quality of data that we are going, right? Again, child sitting on a edge of the sofa, if you just say you will fall, and if you don't provide a context that because you are sitting on a sofa which is higher from the ground, you may fall, right? If you just say you may, that you will fall, probably this data is not accurate, not complete. The child will understand eventually after falling few number of times, but we could have easily avoided those falls if we give the accurate, complete and correct information, right? So the quality of data, quality of experience that we are going to give also matters a lot. Now moving on, in this technology, when we talk about data, we must have the tools to work on the data, right? And don't want to scare you, but there are two important topics from mathematics that are essential for understanding the data. And let's bring on those topic names. All right. So those two topics are basic statistics and probability. Excuse me. So, and please don't think that we are going to talk about a lot of formulas. Although, if you want your career to be in data science, and the role of that is data scientist, right? So, if you want to be a data scientist is a role where you work a lot more on mathematics part, where you will work on your data and try to understand your data by applying a lot of mathematical knowledge, right? So that is the role of data scientist. In this session, we are probably moving away from a data scientist role to a machine learning engineer, Gen AI engineer, right? But it is still very important to talk about statistics and probability, right? Now, in statistics, remember your school time, probably in grade 7, 8, 9, 10, sometime around that, you would have heard the words like the mean, right? Which is basically the average of your data, right? At this time, You just need to recall those concepts if you can. If you don't recall those concepts, it is perfectly fine, right? But we cannot move ahead without talking about this thing, right? So mean, when we talk about, is the average of our data, right? Let's put an example. I have a team of 10, right? One is a program manager, one is a software tester, and rest 8 are developers. What are you going to call this team as? Is it a team of program managers? Is it a team of testers, or is it a team of developers? Right? And the answer is quite simple. 8 out of 10 are developers. So this probably is a distribution. This probably is a data about developers, right? So that is the power of average, right? Then next is median, right? Now median is something when you sort the data in a particular order, either a ascending order or a descending order, right? Then then the center point of that data is what median is. Now all these statistical measures are important to know what our data is trying to tell, right? Think of this team. Program manager, he might be earning a lot more probably than the rest of team, right? A tester might earn a little differently than what developers are earning. But the rest of developers, and depending on your expertise and experience, they would be earning, their earnings would be probably a similar, there will be some disparity, right? Now we want to know as a whole that what is the center point of this. Now think of it, right? Let's put it this way. The program manager earns 100 rupees, right? And the tester earns 50 rupees, and rest of the team earns between, let's say 30 to 70, right? Now 8 people are earning between 30 to 70, and then a program manager at 100 and tester at 50. If you arrange this in a sorting order, right, then probably the salary that you are going to hit will be the salary of a developer, which probably will be closer representation of what your data is, right? However, when you try to average it out, for an example, let's change the example that the program manager earns 1000 rupees. Now when you sum it up, 1000 plus 50 plus all the salaries of the developer and then divide by 10, right? Even 1000 by 10 is basically 100, right? There are 10 people, 1000 is the salary of program manager. If you average it out, 1000 by 10 is 100. That means that the average is telling that everyone is earning around rupees 100, around 100 bucks, right? Is that true? Not at all. We know that our developers are earning between 30 and 70, tester is earning 50. No one is earning 100. But still, your average or your mean statistical measure is giving you a different information. It's not wrong, mathematically correct, but it's a different information. That's where you put another statistical measure, which is median. Okay, let's start the data. So first person with a salary of 30, go on, tester with a salary of 50, go on, the developer with the highest salary of 70, and finally the program manager with highest salary of 1000, right? Now if you want to find out the midpoint of this, that there are people who are at the point position 5 or 6, they will have a salary of somewhere around, let's say 40 or 50, which is like a more representation of your data. Now the point that I am trying to bring here is, and personally, I like this quote, that the biggest myth is created by the factual results of statistics. The biggest myth is created by the facts, right? So here is a fact that the average salary is 100 or more, right? But it's a myth. No one is earning 100, right? So statistics plays its own importance, but we all have to understand that you cannot just rely on one statistical measure and then generalize it. All right, then there are more statistical measure like the mode, which basically is how many times the data is repeating, the variance and the standard deviation. All of these are statistical measures that basically tries to tell you that how your data is. Unless you understand your data, we will not be able to understand, or we will not be able to bring out the right knowledge from our data. Now the next concept that we will be learning, not in this session, but as a data scientist we should be aware, is the probability fundamentals. Now why probability? Now remember, the purpose of every machine learning program, every generative program, every database program is to make a prediction based on existing data. Now the prediction, when we say, might be correct, might not be correct. So probably it is correct, probably it is not correct, the prediction, right? That's where the probability will come into the picture, right? So there is another aspect of data science, which is probability, which we should be aware of. We are not going to talk about both of statistics and fundamentals, probability fundamentals in this session. It's not needed. Anyone who want to understand machine learning and Gen AI, good to learn statistics and probability, but you don't need to get into the real depth. Now let's move on to the next thing, where we want to understand, once we have these tools with us, what are the different techniques to understand our data. So that is data analysis techniques. In machine learning world, you will hear a word which is called as exploratory data analysis. And I think the word itself is very self-explanatory, right? We are trying to explore the data in a way where we want to understand what is the underlying patterns, what are the trends, what is the relationship in our data, right? This is the very first step that most people, most machine learning engineers, data scientists will do, right? They'll just explore the data. They are given a data, and they are given a problem statement, they are given a mission statement, that based on this data can you do this for us, right? So based on this data, so what that data is, we want to know more about it, and the phase of knowing more about that data is exploratory data analysis. It is also called as EDA, right? And this is a terminology which is frequently used in this world. Next terminology that is frequently used in this world is feature engineering. Now, before we talk about feature engineering, I want to focus on the first word, feature, right? It's another terminology which is frequently used in data science world. Now, think of it, that let's say we have an Excel with three columns, right? One is the age of a person, right? Then next is, let's say, experience, working experience, and third is the salary, right? Now we are given three columns: age, working experience, and salary. Based on age and working experience, salary is derived, right? As an example, right? If there is someone who is, and I don't want to create any debate here, right? Anyone with a lower age and with more expertise can have a lot more salary. But let's talk about the general world, right? We can assume that people who are younger in age will have lesser work experience, and probably their salaries will be less than the people who are older in age, a little more older in age, with a little more experience, will have more salary. But remember, as we grow old, especially in the technology world, the age will catch you up very fast, right? So your age will continuously increase, your working experience will continuously increase after a period of time, but your salary will remain stagnant. I am very sorry for those guys. We all are part of the same boat. All right. So uh, the column age and the column working experience is our input, and salary is something that we are trying to predict based on age and working experience. So age and working experience becomes our feature. You can call them input, but in data science world they are called as features. What are the features available, right? And salary. which is the output we are trying to predict, is actually and generally called label, right? So based on features, we are trying to predict a label, right? And don't restrict your imagination on numeric data only. The same example can easily be applied to non-numeric data, right? And one of the most general example is that whether a person will buy a product or will not buy a product, right? So based on his, let's say, salary, or based on his income, you might say that a person will buy a product or not buy a product, and then there can be n number of inputs, there can be n number of features which will derive the decision. So your output need not necessarily be a numeric number like a salary. It can be a label of different types as well, whether he want to buying a product or not buying a product. So in that case, the label will be yes or no. Now, what is feature engineering? Feature engineering is where we are trying to engineer our feature. We are trying to bring new feature based on the existing features. We are given only two columns, age and working experience, right? But we might want to bring a new feature out of our existing feature. And when we derive a new feature, or when we derive an existing, when we change our existing feature in a different way, all that technique is called as feature engineering. Common techniques in feature engineering: feature selection. We want to restrict ourselves to only take those inputs which are important in our decision making. Let's say salary, if we know salary is dependent on, let's say, age and working experience, right? And there is another feature which is name, right? So probably we can relate that name will have very less importance, or very less relationship on what a person is earning, or what his or her salary is, right? So we might have an input feature called name, but we can assume, or probably we can even deduce the fact that name has very less impact on what salary is. Salary is mostly driven by age and the work X columns, right? So that's where we are choosing the relevant features. And as I said, feature creation is where we are trying to bring up new feature out of the existing knowledge, right? Now, we talked about data science. We talked about two important things, EDA and feature engineering, right? Now, if anyone who does these two slides and spend, let's say, next 2 months and 3 months in deep diving into these topics and and a lot more, he will be heading towards a data scientist job, right? We will move our journey from the data science world to the next world, which is machine learning, right? And I hope that you guys are ready to hop the space shuttle to our which will take us to the world of machine learning, right? So congratulations to all of you for completing this data science section and ready to move on the machine learning sections, right? Now, very first thing that we want to talk about machine learning is algorithms, right? Let's let's get back to our child example, right? What is an algorithm? This is another terminology that you will hear a lot more in the machine learning world, right? And when you start working into it, you are going to get confused between two words, out of which one word is algorithm, and we'll talk about it. And just in the next section, we'll talk about the second word. So algorithm is the blueprint where a set of rule or procedure is applied to solve a problem. The learning process for algorithm is it learns on patterns from data, right? Now, remember the child example? The child has a brain. That's the algorithm, blueprint, right? It can process the information. How to process it will come when we expose the data to it. So what is an algorithm? Just a blueprint which is capable of making decision if we expose the data to it, right? And there are different type of algorithm in machine learning world. Linear regression, is something when we are trying to predict a numerical value like a salary, right? And then there are other algorithms like decision tree, neural network. I don't want to bombard you with these big words. I try to keep the examples simple, and don't be overwhelmed with the word neural network, right? Just think that there are different type of algorithms, there are different type of blueprints which our data scientist team have built for us to use. For us means for the machine learning people, machine learning engineer to make use of those, right? So who created this algorithm? Mostly data scientists. And this is the second word which most people will discover while they spend few months or some years into the machine learning world. The second word is model, right? And I hope that you guys will find eventually fortunate enough that you know the difference between an algorithm is a model, right? The child example, right? Brain with a blueprint. When you give the data to it and when the child is a grown up, that is your model, right? What is a model? A model is a blueprint with the data, right? Another analogy we might want to think about is think of a class and the object, right? People from the object oriented world, right? Class is a car, just a template, just a blueprint, right? BMW is an object, right? Audi is an object, right? Or some other. I don't want to promote these two brands. I'm just talking about what came in at the top of my head, right? So an object is a tangible thing which is implemented using the template. So our model is a tangible thing which is implemented based on the algorithm. Our model is the mathematical representation of the learned patterns, and model is something that you are going to make use to make the predictions. The algorithm is a blueprint. You cannot use the algorithm without the data. You cannot just use the algorithm and expect it to perform predictions, while you should expect your model to understand the data and then perform the predictions that you are liking. All right, let's continue our journey. And here is a small quote. Algorithm is like a recipe for baking a cake, and our model is the actual cake baked with your ingredients. Now focus on the word your ingredients, your data, right? So your data is your ingredient, and better the ingredients, better is the cake, right? Delicious is the cake. All right, let's hop over to the journey of machine learning, right? And yeah, here is the small animation. That's all the interesting thing that I can do in PPT. All right, what is machine learning? Machine learning enables system to learn and improve from experience without being explicitly programmed. Now the word that I want you guys to focus on, without being explicitly programmed. So for all the developers who have spent a lot of years in the technologies where which are other than machine learning, right? And I am personally have spent a lot of years in that in those type of technologies as well, right? Whatever program that we write, it follows a very fixed path, right? As we discussed earlier as well. If the inputs are same, then we can expect the same output no matter we run the program once or we run the program a million times, right? However, in data, right, in machine learning, we expect our program to be intelligent. We expect our program to make deviations even if the inputs are same, right? So that's what we want our programs to learn from our data, right? Don't follow fixed path. Now what are the types of learning? One is a supervised learning. Supervised, as the word says, where you are telling your models. Now remember, I'm not telling algorithms, you're building a model, right? So you're telling your algorithms that here are my input features, here is my output label, understand the pattern, right? Now the algorithms which are built by our friendly data scientist team, right? We are going to we are going to make use of those algorithms and hope that we have chosen the right algorithm for our data, right? So in supervised learning, we are telling the algorithm, here is the input, here is the output. We are going to tell it 100 times, 1000 times, a million times, not a million times generally, but 100 times or 1000 times, right? And we expect our algorithm to learn the patterns on that existing data, and the algorithm which is trained on our data is returned as a model that we can make use to make prediction on new data, right? So in supervised learning, we are giving the input, we are also telling the output and asking the algorithm to learn about it. While in unsupervised learning, we are telling to our algorithms that, you know what, this is my data, and even I do not know what this data is about. Can you bring some sort of knowledgeable information out of this? The algorithm or the algorithm might ask, what type of knowledge? We'll say we just don't know what is the output, what is the outcome, what is the label here. But this is some piece of information, some cluster of information. Try to understand this, right? So that's where we are asking our algorithms that we don't know what we want, but can you derive something out of it? So that type of learning is an unsupervised learning, right? And finally, a third type of learning, which is called as reinforcement learning. Given that we are still into the introductory world of data science and machine learning, we will keep this to as simple as possible. Reinforcement learning is little different than supervised and unsupervised. Reinforcement is where we will ask our model to make predictions, and if the predictions are good, we are going to reward our model that yes, you made a good decision, right? And when the decisions are not as what we wanted, we are going to penalize model, our model, right? That no, this is not a good decision. Now think of it. This is an example which this is a type of learning which is mostly used in the world of gaming, right? When you are playing a game, if you do the right things, you are going to get a reward. But if you do a wrong thing, you are going to get penalized, right? So reinforcement learning is majorly used in gaming industry. Again, we want to stay as simple as possible, so we are going to focus out of these three types of learning. We are going to focus ourselves on supervised learning for this particular session, right? Now when we talk about machine learning, now we understand what are the types of it. What are the steps in machine learning? That's what we are going to see, right? All right, another quote. The purpose of each machine learning program is to perform prediction that we have spoken about, right? Why we are doing machine learning? Because we want our program to be intelligent, predict, tell me the future, right? All right, machine learning steps. Here you can see that I have highlighted few of the steps in orange and remaining are grayed, right? For the very same reason that we have at the bottom, right? So these are the different steps that are involved in machine learning. I don't want you to read all of these immediately. Just focus on the first three steps of what we are doing. The first step is define the use case, right? Now this is very important, right? As a machine learning engineer, you want to define what you want to do, or sometimes your business will tell you that what you want to do based on your data, right? So before you start doing anything else, you must define what is the program supposed to do, right? Don't worry what data is available. Don't worry whether it is a classification, regression, what type of problem it is. Just think that what is it that the business or me want this program to do. That is defining your data, right? Now there are two important words that I spoke. One is regression. Whenever we talk regression, we are trying to predict a continuous value, right? let's say as an example, a salary can be a continuous value, right? Whereas in classification, we are trying to classify the prediction, whether it is a yes or no, true or false, right? That type of thing comes into classification. And then there are some predictions like we talked about reinforcement learning. So uh, that type of problems fall into that category. But again, to keep things simple, we are going to predict a numerical value which will fall into the world of regression, right? The second step after you define your use case is know your data. Very important. We talked about it in earlier as well. And how we are going to know our data? With the help of exploratory data analysis. So now we know what we want to do. We have our data. The next step that we are going to do is explore our data, perform EDA, perform feature engineering, right? Derive new features, derive new inputs, right? And finally, one of the important steps is also visualization. There is a very uh, famous quote here: "A picture speaks more than 1,000 words." Obviously, right? If you yourself read data which has 100 rows and 10 columns or 20 columns, you will easily be overwhelmed with the information that is there. But when you try to put this particular data in a picture, in a bar chart, pie chart, whatever type of chart you want to do, your brain will be able to visualize and will be able to understand the data lot more than what 100 rows and 10 columns can give it to you, right? So that's very important, the visualization skills when you perform data analysis. All right, let's move on. And the algorithm selection, right? Remember, the data that we have, the next step we want to do is, all right, my data is, as of now, I'm talking about numerical data. I want to perform regression. And if I want to perform regression, which means predicting a numerical value, I want to pick up algorithms which are good in predicting numerical values, right? So in machine learning world, you may encounter algorithms which might be, yeah, I won't say hundreds of them, but at least you will encounter 10 to 20 different type of algorithms, right? And there are far more algorithms. I'm only talking about the popular algorithms. Out of even those 10 to 20 algorithms, you know that out of these 10, which algorithms are going to fit my data, right? So the next decision that you are going to make after your EDA is, which are the algorithms which I think probably will fit my data. And don't worry, it's not a final commitment, right? You pick up one algorithm or you pick up more than one algorithm, run your data through that algorithm and see whether that algorithm is able to build a good model out of it, right? Now, what is the definition of good model? We are going to talk about it. But at this time, after doing EDA, we are saying that we have to make a decision that which are probably the algorithms that I want my data to run on. Moving on, the next step after algorithm selection is model training. As the word says, model training. We are training our model, we are training our algorithm, right? So the data which I have refined, which I have feature engineered, right? That refined data I am giving to my algorithm, right? And I'm expecting that with this refined data, the algorithm will bring up a very nice model which will give me the right predictions. Now, what we are going to do is experiment with different algorithm, and there is one more terminology that's coming here, hyperparameter, right? Now, most of us would have heard the word parameter, right? When I started my career in data science and machine learning, I was also confused for a lot of time that what are hyperparameters, right? Hyperparameters are sounds similar to parameters, right? Hyperparameter is just I would call in my understanding that they are type of a specialized parameter. What does it mean? Let's go back to our child example, right? The child has a brain, right? It can think. Now hyperparameter is where you decide that how many times I am going to feed that brain, feed that algorithm with the instruction. I can tell only once, don't sit on the edge of sofa, you will fall, or I can give repeated instruction, right? Now there is a very there are the pros and cons of both of the approaches. If you give too less instructions to your child, if you just say once that don't sit on the edge of sofa, otherwise you will fall, right? The algorithm may not be able to perform well. On the other hand, if you tell every possible combination to your algorithm, right? Don't sit on the sofa, you're gonna fall. Don't sit on the chair, you're gonna fall. Don't sit on the table, you're gonna fall. You have defined all the possible scenarios to your algorithm. The algorithm will work perfectly well. On the sofa, it knows don't fall. On the chair, don't fall. On the table, don't fall, right? But when it is given altogether a new scenario, right? When it is sitting on a park bench, oops, I did not have any instruction about park bench. So while it will work very well on the scenarios that you have given, it may not work well on the new scenarios. So hyperparameter helps us in deciding how many types of instruction we want to give. It should not be too much, it should not be too less. And there are two important terms that you will learn in regarding this particular example. One is overfitting and underfitting. Overfitting, you tell everything to your algorithm. The algorithm works well for all the scenarios that you have told, but it works very poorly for any scenario which is outside of this scope, because you did not give a chance to your algorithm, you did not give a chance to your child to make decisions. You were rather instructing so many different scenarios that it works well in those scenarios, but it has no decision making, right? Same goes for the other case, underfitting. You give so less instruction to your algorithm that it has to make its own decision and then see whether it's a good decision or a bad decision, right? So hyperparameter helps us tell that how many times we want to give the instruction. We are not telling what to do, we are telling how many times to do. So it's a parameter on top of another parameter, right? That's why it's called hyperparameter. All right, in machine learning steps, the next thing that you are going to do is model evaluation. And two things that I would like to reiterate. Model, when we talk about it, it's a software program. And another example that I am putting again and again is the example of a child, is the example of a baby, right? Now, please understand, I know we are moving ever so fast and bridging the gap between machines and humans, right? But still, there is a long way to go. We all are humans. So, for this particular case, model evaluation, when you are evaluating, you observe your child, don't evaluate, right? A child is a human, he or she is not a program, right? Just a little bit of philosophy, right? But in the world of machine learning, evaluate your model, don't observe. That means that your model, your software program, whatever predictions it's gonna do, right? You have to evaluate it. Then only you can tell that whether my algorithm is working correctly or not, and don't blame it on algorithm only, right? The algorithm might be a great algorithm, but the data that you are giving is not the best for it, right? So the decisions that you are getting, the model output that you are getting, can be a combination of bad algorithm, can be or a bad data, or a club of both, right? So you have to evaluate the outcomes and then try to ascertain what is going wrong, right? To evaluate the model, there are different type of metrics, like a mean squared error or a confusion matrix. Now don't get overwhelmed with the word mean squared error or confusion matrix, right? Because these are just a metric which tells that whether your model is evaluating correctly or not, right? As an example, if your model was expected to predict a value of 10, and if it predicts a value of 1000, it is way far from what it was expected, right? If it predicts the value of, let's say, 12, and the actual value what we were expecting is 10, it is close, right? So you don't need to have this type of metric as well. You can define your own metric. My own model evaluation metric is basically just the difference between the actual value and the predicted value. That's it. Simple, right? But at the end, you will have to either use existing metrics or derive your own metrics, and then understand that how is the quality of the prediction by the model. So in machine learning, the next step after model training is model evaluation. Once you are done with model evaluation, and let's say you are happy with the metric that you are getting, okay, my model is giving me the greatest prediction and I am ready to tell the future, right, based on my model, right? So you have your data, you have chosen the algorithm, you have built your model, a tangible thing, right? And it is working perfectly fine. That's the end. In one sense, that's the end of development, right? At least the first iteration of development, you have evaluated, you are successful with, you are happy with the evaluation. Next, as a machine learning engineer, you are going to deploy the model, right? You cannot keep your model in the development environment only. Eventually it has to go out and do the real world thing. You have built the ship at the harbor, right? The ship is big, strong, everything, right? But that's not what the ship is meant for, right? Eventually it has to go into the sea, right? So that's the deployment part, where in the machine learning world, you are going to store your trained model in some compatible file format. Now the model is there, right? You want to push it to a different machine. Your model is still a program, right? You have to package it, and that packaging is done in one or the other file format. One of the file format that you will hear in traditional machine learning is a pickle format, right? And don't get again overwhelmed with this file format. Just consider it that it's a file format which helps you to move your model from one machine to other. You can also zip your model. You can also create Docker images for your model. Again, don't think too much. Just a file of your model, and this file will contain your trained model, right? This is your trained thing which knows how to work with your data, right? So that's the deployment part. Now in production usage, what are you going to do? You have zipped your model, you have moved your model package from your development machine to a production machine. Now this is a zip file, right? It's of no use until you have a program that can read this file. So that's where the production usage come into place, right? In the production environment, you are going to retrieve your stored model, right? And then you expect that when this model is running, when this program is running, then this program will perform predictions. Now, the way predictions can be done are in two parts: either an online deployment, which means a real time. That means the program is continuously running. You just, let's say, age, work experience, and salary, right? Your model is trained. Next time you give the age and a work experience of a person, and it will give you it will predict the salary for you, right? So this type of inferencing, this type of prediction is called real time inferencing. You give the input now and get the output immediately, get the prediction immediately. It's called real time. Benefits: it is real time. And disadvantages: it will run even when you are not using it, right? So you ask for this prediction only once a day. So it will run it for 1 minute, and remaining 23 hours and 59 minutes it will be sitting idle, right? So if that is your scenario where you are going to perform the prediction only a few times a day or a very specific times of a day, in that case probably another type of deployment is what you would like it as a batch processing. where you are going to awake your sleeping model. That means that you have deployed your model on the production system, but it is not continuously running. Whenever you give the input to the data, there will be an additional step where the model will be invoked again, right? It will take a little bit of extra time, but it will give you the same predictions, and once the predictions are done, it is going to sleep again, right? That means that if you are going to run your prediction for 1 minute or 2 minutes, your cost will be just for those 2 minutes, right? Rest of the time it's sleeping. That's another type of deployment that you will hear a lot more in the machine learning world, right? And we are ready to move out of the machine learning world to either a SageMaker or Azure Machine Learning Studio, right? All right, enough of theory. Let's go to the workshop and make things. Yes, I agree, right? We have learned a lot of theory, and I think with this introductory session of data science and machine learning, we have enough to head to our workshop where we are going to make things. The first workshop that we are going to hit is our AWS SageMaker. Oh, one last thing before we get into workshop: programming languages. Right, so we have to pick some tools before we get into it. The most popular choices of programming language in machine learning is Python and R. We are going to focus more on Python. While I think I'm not an expert of R, but I believe that almost whatever you can do in Python, more or less those capabilities, you can do it in R. And these days there are more options of programming language. But I think that Python remains the by far the most popular language for doing machine learning and generative AI. Python libraries, these are small programs which helps you to get started. These are boilerplate libraries like a NumPy or Pandas for numerical and data manipulations, right? So NumPy is just a small Python program which helps you to work on numerical data, right? You don't have to build your own library from scratch. You import this, use the function, get it done. Pandas, same for data manipulation. Since we are going to do a lot of data manipulation, a lot of data reading, a lot of data writing, one of the most famous library, most popular library is Pandas. And for data visualization, there are libraries called as Matplotlib or Seaborn, right? Now, again, these are libraries that are going to help us to to avoid doing some rudimentary tasks. And as I said, there are hundreds of more libraries that we are going to work upon, but we don't need to worry. We don't need to know all those libraries. Just think of it that whenever you want to do something specific to your use case, consider that the boilerplate, the introductory, the initial library is already developed by someone, right? And of course, we are going to talk about basic programming concept like the variable loops and functions. And the best thing about, I won't say the best thing, but an easier thing about machine learning is there is a lot more that you have to think about while building the program. But the easier thing is there is far less coding that you will be doing in machine learning world. Far less, right? So a person who has a basic programming knowledge will do equally well if he or she is able to think in terms of data science and machine learning, right? Thinking is more important than programming. You are not going to need a lot of big frameworks and configuration files and this and that. All of this thing is very simple in Python and machine learning. No exhaustive programming. All right, so with this we are all set to go to the workshop. The first workshop that we are going to visit is AWS SageMaker. Bring it on. SageMaker, what's in the name, right? William Shakespeare, probably some centuries ago, he said that, right? And it's a very famous quote, and he is the super famous person. What's in the name? But in these days, at least I believe that there is a lot in the name, right? So whenever I am learning about any new thing, and if it is given a name, I try to find the meaning of that name. You know what? Only by finding the meaning of that name will give you a very good start in understanding that particular thing. Let's say SageMaker, right? You will go on the internet and you will get the regular formal definition. Oh, SageMaker, machine learning platform, and you can do this and that and blah blah blah. What is SageMaker? Why it is called SageMaker? Is I think the very first thing we all should try to know. And not only SageMaker, whatever new jargon, whatever new terminology that we get to know, try to find the meaning of that. Now, what is sage? People who are very good in English, right? They would know. A sage, or and people who are not, who do not read a lot of English apart from technology, like me, right? A sage, more or less, I knew what is a sage, right? But the better way of defining it is a sage means a wise and knowledgeable, especially as the result of a lot of experience, right? A sage, right? A person who has a lot of experience, who's knowledgeable, right? Is a sage. Now, sage maker, right? This particular tool is going to help you make a sage. A sage is your machine learning program, right? You can build a knowledgeable program using this tool. So SageMaker will help you make your own Sage, your own knowledgeable program, right? That's how I treat this definition as. And of course, the internet definition, AWS SageMaker is a fully managed platform for building, training, and deploying your ML models, right? We talked about all of this, right? What does building means, what does training means, and how we are going to deploy it, right? Why SageMaker? Why don't we do it in our local computer? Well, you can do it in your local computer, no problem at all. But while the world is moving on cloud technologies, which are which gives an immense benefit, right? Now think of it that in the pre-cloud world, right, when everything more or less you run it on your own personal computer, or in an organization you run it on your prem, right? So you need everything to be set up before you write the very first line of code, right? Even if today on your personal computer, if you want to do, even if you want to print hello world from a Python program, forget about machine learning programs, right? You will need to install Python. You will need to go over internet, and if you are new to it, you are going to get 20 different links over Google. Install this, install that, this is this, this is that, and then you will be lost, right? SageMaker takes care of all the infrastructure you need. You just go, log in, and create a program. Don't worry how to install Python, what libraries, what infrastructure, what machine, right? However, I strongly suggest that all of you who are doing it for the very first time, they must try to install Python in your local. And there is a famous, very simple package which is called as Anaconda. You go, if you are a Windows user or a Mac user, just go download Anaconda and install it. Immediately you will be able to write the Python program, right? I'll try to cover installation and usage of machine learning programs in personal computer as a separate video, right? For now, let's focus back on our SageMaker journey, right? Hmm, theory again. Where is my workshop? It's coming. I think we are pretty much done covering everything at the introductory level that we wanted to do, right? So in the next video, we are going to jump right over into the world of SageMaker. We are going to create, or I'm going to tell you how to create an AWS account, how to log into SageMaker and build your very first machine learning program. So till then, sayonara and fir milenge. And this is a little quote from the Matrix style. Hope I have earned a coffee from you. right? Please like, subscribe, and share if I was able to explain you the things in a simpler way. If you have any inputs, anything that you would like to know in detail, or anything where I have missed explaining it in a proper way, please do let me know. The intention here is to share the knowledge and share it in a way where most people can understand. I tried my best. Please help me improve by telling me what went well and probably what needs an improvement. All right. I'm going to see you into the next video. Until then, thank you.